So what I want to do right now is I want to connect induction to something more concrete. So we want to connect mathematical induction with programming. And the way we're going to do that is through talking about while loops. So in particular, we're going to talk about something called the loop invariant theorem. So basically, this is kind of a way of determining if your while loop is correct or if it does essentially what you want it to do. So let's say we have a while loop that has some kind of guard to it that's guarding the loop. We need an I of n, which is our loop invariant. And so what the loop invariant theorem says is if the following four properties are true, then the loop is correct with respect to its pre and post conditions. So there's four properties. So the first one is called the basis property. And it says that the precondition for the loop implies that your loop invariant I0 is true before the first iteration of the loop, the first time that the loop is done, the first iteration of the loop. So this part is very similar to the basis step in induction, that this is saying that your loop invariant is true for the initial value 0. Okay, then part 2, or property 2, is that it's called the inductive property, which says for every integer k that's at least as big as 0, if your guard, if the guard G and the loop invariant I of k, whatever k is, if they're both true before an iteration of the loop, then your next value, I k plus 1, is true after an iteration of the loop, after an iteration of the loop. So this is very similar to the inductive step for induction, which the inductive step says if pk is true, then pk plus 1 is true. This is very similar to that. And then the other two properties come from the fact that you're talking about a program. And so the third property is called the eventual falsity of the guard. So eventually your loop has to terminate, essentially. So after a finite number of iterations of the loop, the guard to the loop, so the guard G has to become false. So eventually you stop doing the loop because the guard becomes false. So you can't enter the loop again. And then the fourth part says that the correctness of your post condition is what it's called, which says if n, capital N, is the least number of iterations after which G is false, and I of n is true, so it's the least of the number of iterations it can perform, then the values of your algorithm variables will be as specified in the post condition of the loop. So after it terminates, it's saying that it's gonna, the last thing done in the loop is what the values of the algorithm variables will be as specified in the post condition of the loop. So whatever comes out of the post condition of your loop, then that becomes your algorithm variables, the values of those. So again, this is something very, very specific, but it is very related to induction. In particular, properties 1 and 2 are essentially induction, and 3 and 4 are just extra properties that you have because you're working with programming and you need, like, your loop has to terminate. It can't go on forever and ever.